ASTM D3080, standard test method for direct shear test of soils under consolidated drain conditions. Necessary equipment for completing the ASTM test is a direct shear test box, as well as the accessories, a balance to the 0.01 gram readability, a measuring device such as a caliper and or ruler, soil specimen, a bowl, as well as a tamper. Finally, a funnel will be necessary. Next, measure and record the inside depth of the cell without sand. Next, measure the thickness of the base plate. As well as measuring the thickness of each gripper plate. This will be used in further calculation for determining the height of the sample. Finally, located on the shear box is the diameter of the sample. Generally, one is to measure and record the mass of the shear box before and after filling it with sand, but for the purposes of this lab, we will deviate from that and record the mass of the sand in the bowl before and the mass of the sand in the bowl after we fill the shear box. This will be discussed further in the lab video. Next, fill the shear box with sand using 3 separate lifts, tamping each lift, keeping the sand below the side screws. With this, record the remaining height from the gripper plate to the top of the shear box. Again, this will be used in a calculation that is discussed in a subsequent section of the video. After recording the final mass of the sample left over in the bowl, one may begin the actual shear test procedure. Insert the shear box specimen into the loading machine. Place the loading cap and frame without weights on the sample. Take the construction screws out, gap the sample, add weights to the loading frame, and then ungap the sample. Position and zero the dial gauges, horizontal deformation, vertical deformation, and shear force. Designate group members to track required data gauges. Tau equals F over A, where tau equals the nominal shear stress, F equals the shear force, and A equals the initial area of the specimen. Sigma equals the normal stress, N equals the normal vertical force on a specimen, and A equals the initial area of the specimen. The weight of the sand, as discussed previously, is calculated simply by taking the initial weight of the sand in the bowl and subtracting the final weight of the sand in the bowl. The height of the sample is going to be the height of the box minus 2 times the height of the gripper plate minus the height of the base plate minus the height of the air gap. When all necessary calculations have been completed, One must plot the shear stress versus the horizontal displacement in Excel. Next, plot the horizontal displacement versus the vertical displacement. Include all specimen data on the same plot and label the normal stress for each curve. Finally, plot the Mohr-Coulomb failure envelope. This is the normal stress on the x-axis, shear stress on the y-axis. Both axes must be on the same scale. Determine the friction angle for the material and label it on the plot.